All right, good afternoon, everyone. Thank you for coming to join me in this presentation today. I will do my best to be more exciting than the lunch that's being served in the boxes. Thank you. I'll be here, well, all week until tomorrow. I've been told, those of you on the left side of the room, if you prefer not to sit in the Arctic tundra, the right-hand side of the room is more like outside and hot. So if you're too cold on this side, apparently all the AC is blowing on this side of the room and not over here. So it's a little warmer on this side if you get cold. So welcome to SQL Server 2016 High Availability and Disaster Recovery in Private and Hybrid Cloud Deployments. I think this is officially the longest title that Microsoft has ever given me for a presentation I've given for them. My email address is up on the screen. It is not at the end of the deck. I just looked. I do have some business cards up here on the speaker up front. If anybody wants to grab one at the end of the session, please feel free. Rest of my contact info is here. I am a Microsoft MVP for the data platform track, or data platform part of Microsoft. We used to be SQL Server MVPs, and that was much easier to talk about. I will find out in exactly 2 more days if I get to say I'm an MVP for another year. My renewal date is October 1st. Fingers crossed. Otherwise, it's going to be awfully embarrassing as I fly home from Ignite. I am a Microsoft Certified Master for SQL Server 2008 and 2012. I am not a Certified Master for 2014 because they canceled the program. Not that I'm bitter or anything, but yeah, kinda. My Twitter handle is up there, as is my company URL, which is dcac.co. So what we're going to talk about over the next hour and 13 minutes, I can do basic math, is always on failover clustering, always on availability groups, and what that last bullet point says there is SQL Server 2016. And we're going to talk about some of the various permutations we can set up for those, and a little bit of how those are going to work in various deployments, both on-prem, in the cloud, and how we can stretch things between those 2 environments to really get the best out of everything. We're going to touch a little bit on Windows Server 2016, how that's going to work with SQL Server 2016 to get some of the best features out of both of those products when we combine those together. Obviously, Windows Server 2016 being out in the market for such a long time as it was announced on Monday. So we've got quite a lot of experience with that, obviously. So first thing I want to talk about is our traditional failover clusters. So with the failover clusters, this is the same approach we've been doing for umpteen years now. First introduced back in the SQL 2000 days when it worked awesome. I forgot to ask, where are my DBAs? Okay, about half the room. You're probably all the DBAs at the entire conference. Good to know. Where are my developers? About 6 of you. Okay, I'll try not to make too much fun. Systems admins, I'm assuming it's a bunch of you, about a third of the room. Okay, management. Way too many of you in one room, okay. And most importantly, anybody work for Microsoft? No, excellent. We can have more fun that way. Anybody already running SQL Server 2016? Actually, that's a decent number, maybe a quarter of the room. Okay, cool. 2014. This is where we get our exercise for the day, besides walking around the convention center. About half, okay. 2012? About 2/3 of the room. 2008 R2, this I assume is most people. Okay, yeah. 2008, a few brave souls. 2005, a few crazy souls. 2000, a few people that need to upgrade. SQL 7. No hands for SQL 7. I'm in one hand? One poor one. Oh, a couple of people. Okay, 6.5? No? Okay. So there are still people running SQL 6.5, just to be clear. I do this at every session I try to give, or at least I try to remember to. Some poor soul in England, when I was at SQL Bits a few months ago, was still running SQL 6.5 in production. I pity him. I laughed at him, but I pity him. All right. So when we are building our failover cluster, there's obviously some prerequisites. I didn't even go out last night that we have to deal with. Obviously, the first one being we need to deal with failover clustering. We need to get that Windows cluster set up to get the SQL Server failover clustering configured. Microsoft, or the SQL Server product team rather, has not built their own failover environment in failover clustering. They're letting the clustering team deal with that. The clustering team does do a very good job of failure detection and moving services and restarting services and dealing with resource ownership and stuff like that. So the SQL Server team is letting the team that does that professionally deal with that. And I think that's a good thing. If we all remember database mirroring, you'll probably all agree with me with that statement. We have a single set of database files. So we do technically have that single point of failure. Now that said, this is going to require shared storage. So that storage array itself is going to have a lot of redundant components built into it. But we do only have one single set of data files within a traditional failover cluster. So if the disks become corrupt, or if we delete data, or if we lose a LUN or something like that, we've lost the production copy of that data. So that is kind of the risk when using the failover clusters. Now, failover clustering is available from SQL Server 2000 plus, and it's still available in SQL 2016 today, and it is not going anywhere. And there's a lot of situations where you need it, and you can't necessarily use an always-on availability group, while you do want that high availability that we do get from failover clustering. And we'll talk about some of the limitations of of the availability groups when we get to that section. So basically what we're doing is we're configuring multiple instances, one per server, to all use the same set of database files. Now there's nothing real tricky that we have to do this. The installer is going to take care of all that configuration for you. When we do the installation, we just tell it on the second node we're installing that you are just going to point to this set of database files and this configuration in this instance. And it gathers up all that data from the first instance we installed to make the installation process much simpler and much smoother. Now, even though we have multiple servers, and I'm going to assume the physical world for a minute here, even though we have multiple physical boxes all pointing at the same set of database files, only one set of database files, or only one instance is going to be able to look at and touch those database files at once. So only one of those instances is actually going to be running at any one time. So if we look at a two-node cluster, one node, two nodes, and this box is running the instance, this is the only box that actually has control of the hard drives and can even see the hard drives for the service. This box, the second box on my right hand, that box, the SQL Server service is actually not even running on. So it's actually completely down. So any sort of monitoring that you're going to do, you're going to want to look at the actual cluster name itself, because that's going to just be pointing you at whichever box happens to be online to be able to do whatever needs to get done. So we've only got that one instance. So this is not any sort of scale-out technology. When I first started looking at clusters, before I really started digging into them, I assumed this was some sort of scale-out approach where we could scale horizontally and get more horsepower. Unfortunately, it is not. We still can only scale vertically in this sort of solution. Click. There we go. So this is basically what our failover cluster instance is going to look like. We've got two nodes, which are those big orange boxes in the middle there. So we've just got them labeled as node A and node B. We've got a cluster name on top of that. That's the name that our users are going to connect to. So we may call the boxes SQL 01A and SQL 01B. Those are our physical boxes. Then we may call the SQL Server instance SQL 01, and that's the name that our users connect to. If they were to try to connect to either of the other two names, SQL 01, SQL 01B, or node A and node B in our picture here, they would not be able to. SQL Server, in the newer versions of SQL Server, only listens on that shared name. It does not listen on any of the local names. Now, back in the older versions of SQL, like 2000, 2005, and I think even 2008, it would actually listen on the local name as well. Well, this could get dangerous, because if a user was used to connecting to node A, and I move the SQL instance to node B, when they go to try to connect to node A, there's no SQL instance to connect to. Now, underneath those nodes, we've got our shared storage, and that is traditionally SAN storage. In the modern days, that could be a network share up on another server, on a file share. Some of the NAS appliances can be used as well. Pretty much anything that's an SMB 3.0 or above target can be used as a file share, because those are going to be running at basically wire speed. I mean, there's a little bit of overhead for SMB, but it's not like it was back in the Windows 2008 days or anything like that. We can actually get really good performance out of that SMB3 storage. So with our SQL Server in a failover cluster, we have the ability to simply move that instance back and forth between these two machines. Unfortunately, it jumps back because my slides are not configured to allow me to gracefully fail it back and forth. So this gives us the ability to move that workload from one box to another. So if we're patching, if we have a physical server failure, any of those things happen, that instance just gracefully moves to the other machine. Now, any transactions that are running at the time of that failover are going to be terminated. We are dealing with a service stop followed by a service restart on the other machine. So this is just like if I was rebooting Windows or restarting the SQL Server service on a local box. All threads are shut down. When SQL Server comes online, any transactions that were in flight are going to be rolled backwards. Any transactions that were completed are going to be rolled forwards, just like normal. Typical failover time, 8 to 10 seconds to move the service and get it online. Now, there's going to be a lot of determining factors on that, one of which is going to be how many hard drives do you have attached, how many LUNs do you have presented that are going to be failed over. The more LUNs, the longer it's going to take to fail over, obviously. And then how many databases do you have on the server, and how many cores do you have on the machine. The reason the number of databases and the number of cores are important is because of the startup process. So every time this instance starts up, a process called crash recovery is going to run. Now, crash recovery is a serial process. It's single-threaded per database. And we can run crash recovery on one database per CPU at a time. So if we have a cluster with 100 databases on it, and we have 4 cores in the server, I can run crash recovery on 4 servers at once. So each core is going to run crash recovery for about 25 databases, give or take. So the more databases you have, the longer that process is going to take. I had a client once that had 800 databases on a server and 4 cores, and they were trying to convince me that it should start up faster than about 3 minutes. I had to explain the math. At just 2 seconds apiece, they were actually doing pretty good. 2 seconds per database, because 800 databases time divided by 4, that's 200 databases per core. At a couple of seconds each, we're talking 800 seconds. That's a few minutes. Like, that's reasonable. Like, that's what it should be. The solution to that problem, more cores. Unfortunately for them, they were in Azure, and they were a startup, and they did not have the money for that nice big GS5 that they wanted to run their SQL Server on. They were running on a little GS2. So they did not have access to 32 cores like they wanted. We can take our failover clusters, and we can build them rather wide. Windows Server today supports, I want to say, 64 nodes in a failover cluster. And that's typically, those size clusters are typically used for Hyper-V. A fairly traditional, fairly typical solution in a SQL Server configuration would be something like this, a four-node environment with 3 SQL Server instances running on it. All 3 of those could be named instances, or one of those could be the default instance and then 2 named instances. If we need to move these instances around, we could simply fail one of them over to the passive node, reboot that box, and then either fail it back or leave it where it is. There's lots of options when configuring this. We'd have a variety of LUNs created underneath this, being presented to each of these, or to all the nodes, with a set of LUNs for each database instance that we create. When you're configuring a multi-instance cluster like this, some things to remember. Each one's going to need its own network name, each one's going to need its own IP address, and each one's going to need its own LUNs, and each one's going to need a minimum of 1 drive letter. Mount points are fully supported in failover cluster, especially in a configuration like this. They are highly recommended, because that way everything can be nice and consistent. Instance 1 is the E drive, instance 2 is the F drive, instance 3 is the G drive, and we just use mount points to present the appropriate number of LUNs that we would normally do as separate drive letters. And everything keeps working, and everything's nice and simple and easy to maintain. And more importantly, we don't have to worry about running out of drive letters, because unfortunately I've done that and it kind of sucks. It's kind of a pain to deal with. When you've got to start moving things around, it starts requiring outages, and that's bad. Now, when we're building these failover clusters, each one of our instances is installed and managed independently from everything else within the cluster. So if I've got my 4-node cluster, and I've got 3 instances on that cluster, I am doing 4 times 3 installs of SQL Server to get the instances all deployed out on the boxes. Now this, for the most part, has to be done in series, not in parallel. If we time everything right, we can do a little bit of parallel install, but it can get kind of tricky to manage depending on how big the cluster is. So if you're building a 4-node cluster, book about a day of time, maybe 2, just to sit there and watch the install process going. If you use a scripted install or an automated install of any sort, that can speed that process up because obviously the GUI slows things down as you have to sit there and click on stuff, and we shouldn't need to do that all that often. When you're doing those installs, you are actually manually pushing it out to every node. Back in the SQL 2005 days, the installer would actually push the instance out automatically to all the nodes in the cluster. This was great until it failed, which it did about 30–40% of the time, and then the whole process would roll back, and then you'd have to try again. And that was a kind of a pain. So now every instance is done independently of each other. The really nice thing about that is we can do rolling upgrades from version to version. So I can upgrade my SQL cluster from SQL 2012 to 2014 with about 6 seconds of downtime, because all I gotta do is just fail that cluster over. I upgrade my passive node and then just fail the cluster over, and now it's running on my active node. Talked about that, we talked about that. So we're redefining how we think about an instance when we deal with a cluster. Up until now, when we've had a standalone instance, we've always had that server is the instance. But now that instance is installed on multiple machines, and it's gonna float from one machine to another. So we're gonna have to configure these boxes and make sure that we can have that instance float back and forth between those 2 machines. Since we have that same name, that's the name that we address everything by. That's what we call that instance as it's moving around. We don't necessarily care what piece of hardware it's on or what VM it's running in. We just need to move things around to keep everything up and running, keep things moving. And we need to think more globally about it. We do make sure to remember that each of those instances are gonna have different host names. This is one of the things that's kind of annoying about failover clustering. If I install 3 instances on my cluster, so say I've got my 2-node cluster and I want to put 3 instances stacked on top of that 2-node cluster. One of those is going to be SQL 1, one of those is going to be SQL 2, and one of those is going to be SQL 3. And then 2 of those are going to have instance names attached to them as well, because each one of them has to have their own name and IP address, because they each need to be able to fail over independently of the other 2 instances. So we're not bundling everything together. It's every instance is totally independent of each other in the failover cluster. They have no idea that they're installed on the same box as other instances. When we're building our failover cluster, everybody here's a good portion of the group was a sysadmin. We're probably familiar with failover clustering and how it actually does those dependencies. For those that aren't, here's kind of what it looks like. We've got our instance name and IP address down at the bottom. Those are going to be dependent on one another. So the instance name is not going to come online until the IP address is online, because we can't register a name in DNS until we know what that IP address is that we're going to be registering against. We've got our disks down there at the bottom. Once those are online and the network name is online, then we can bring the SQL service online. So everything's dependent on something else. And obviously once the SQL Server service is online, then we can bring the SQL Server agent online and get everything working. If we didn't bring things online in the right order, then services could fail, because we would have SQL Server coming online before the disks were available. And then obviously that's going to be a problem, because SQL Server can't see its own data files, and now SQL Server is not going to run. Now we have some enhancements in SQL Server 2012 over our previous versions. I just want to touch on these a little bit, because these are actually fairly important. And these gave us a lot of enhancements that we can now use moving into always-on availability groups. And a lot of these things were things that we wanted, but we couldn't get until the Windows failover clustering team actually gave us a lot of this flexibility. So the first one is the multi-subnet failover support. This is the thing that we got that made our network admins no longer hate the database administrators. We leave that for the systems team. The networking team hated us as DBAs because whenever we wanted to build a multi-site failover cluster in Windows or in SQL 2008 R2 and below, we always had to have a stretch VLAN. So we had to have the same IP subnet spread across both sites that we wanted to build our cluster in. Now, I didn't think this was that big a deal. Turns out, one of the harder things you can do in networking. So this always made network teams rather grumpy to have to go deploy because it's such a complex thing to have to do. So with SQL Server 2012 running on Windows 2012, we no longer needed the systems team to do this because we can now build a SQL Server instance with an IP address on both sides. And it would simply use an OR statement to decide which site it was using. It would simply use the subnet of the server that it was currently running on or that was starting on to determine which IP address to use. We also got network storage support for failover clusters. Now, standalone instances have had network storage support or the ability to host their databases on a network share actually for a couple of versions. But we couldn't have that for failover clusters because there's one key thing that was not supported for hosting databases on a remote network share. That feature that we needed was the ability to put the system databases on a remote network share. Microsoft had that feature, or did not give us that ability until SQL Server 2012, which is how we got the ability to run our databases, our clusters, on a remote network share. This is one of the ways people were able to use things like Fusion IO cards or OCZ cards or Intel cards as PCI cards on shared storage, was they put them out in a remote file server on a third machine and have the two SQL servers both pointing to those data files on that network share. Another cool feature we got as an introduction in SQL Server 2012 was the ability to use core mode. Is anybody running anything on core mode today in their data center? A couple of brave souls that know PowerShell. Excellent. So Windows core mode, it's a little more complex to administrate things, to get things set up, because there's no GUI. Who's heard of core mode? Let's do that. All right, about half the room. So the rest of you need to start learning PowerShell. I'm ashamed to admit that I just said that. I am. Don't tell Microsoft, I am not a fan of PowerShell. But it has its uses, and this is one of those places where it is really, really useful. So Windows core mode, for those that weren't aware, is a GUI-less version of the Windows operating system. So you basically RDP to the server, and you're presented with an incredibly useful command line interface. And that is your entire interface to the server at this point. So that's been supported on SQL Server for a little while before 2012 came out. But we just got that support for failover clustering in the SQL Server 2012 environment. This lets us build really thin SQL servers. The less stuff we have installed, the less memory is required, very handy for virtual machines, and the less stuff we have to patch. Also, the less surface area that could potentially be used by an attacker. GUIs require a lot of code to make work, so there's a lot of potential for problems in there. Another really great feature we got in SQL 2012, and again, this is just helping us get along into the availability groups world and making things better overall, is the ability to put our TempDB on local hard drive. So we can put it on local SSD while putting our databases on shared storage. Now, this can be very handy in Azure as well, because we can put our TempDB database on the D drive on any of our VMs in Azure. And as long as you're not on an A-series VM, that D drive is local high-speed SSD in Azure. So we can do these same sorts of failover clusters in Azure using some third-party storage replication technology from a company called Sias Datakeeper. And so we can get a failover cluster, but we can put TempDB on local storage and get the performance we need out of TempDB without spending all that money on premium storage just for our TempDB databases. For our failover clusters in Azure. So we talked about the multi-subnet a little bit. So it just gives us that ability to have those two IP addresses for that SQL Server instance. The failover cluster figures out which IP address to tell SQL Server to use based on just an OR statement. If I've got two sites, this is 192.168.0.1, this is 172.0.0.0. That information is obviously stored in Windows. It's stored in the configuration of the cluster. It just presents whichever IP address matches the server we're running on when the machine starts or when the SQL Server starts up. With the introduction of SQL Server 2014, we got a lot of new features again. Well, we had a couple of new features. We got a lot more in 2016. In 2014, we got shared volume support. This is probably the biggest thing. So as Microsoft was introducing new features in Windows, we had to obviously get support for those in SQL Server. So we got that support for putting our databases on CSVs in our clustered environments. So this allows us to build natively in Windows on-prem a nice SAN-less failover cluster, a failover cluster without any sort of shared storage requirement. Now this just requires Windows 2012 R2 or Windows 10 Server. Apparently I need to update the slide to say Windows 2016 and SMB3 because we've got to move all that data back and forth across all the members of the CSV. But we can now do all this without any sort of SAN support. So we can build that cluster without that single point of failure on the back end. We've got some additional options as well. Now in Windows 2016, we can use storage spaces for our shared storage. This is going to give us block level storage replication between all our servers in that storage spaces environment. Now, unfortunately, this does not work in Azure. There's something that keeps it from working in Azure because we just can't do that storage replication in Azure for some reason. I haven't been able to figure out what yet, and nobody in the product team will tell me because then I'd tell you, and they know better. So this will work with all supported storage in Windows Server 2016. So if you're dealing with SSDs, if you're dealing with any of the new NVRAM storage that was announced this week that's supported in Windows 2016, that's all going to work with this storage spaces. So we can do this with physical servers, we can do this with our VMs, we can do it with local disk or virtual disks or local SSD. It doesn't really matter what technology we're throwing underneath this. We can even do it with the tiered storage that's supported in storage spaces. So we can move the hot blocks to the SSD and the cold blocks to the spinning disk. All very affordable and very easy to configure, and we can build our SQL servers on top of this and really get that really, really good performance with that environment. Now, if you're in a Hyper-V environment, so where are my Hyper-V customers? Don't be shy. Okay, that's not bad. All right, 15, 20%. Okay, that's a lot better than it was 2 years ago. So at TechEd 2 years ago, at our final TechEd North America, they put me in one of the big rooms. I had like 800 people. It was awesome. I asked who's running Hyper-V. One brave soul admitted to it, and that was it. I'm so happy to see so many more people running it. So I'm assuming the rest of you are all running physical servers, right? It's only hypervisor we're going to talk about here. So if we're doing VMs in Hyper-V, which we all are going to be doing soon, I'm sure, we've got in Windows Server 2016 the ability to have a shared VHD file. So we can now share our VHDs across multiple VMs, allowing us to have that failover cluster environment inside our virtual machines without needing to do pass-through disks, without needing to do iSCSI from the VM directly to the storage. Much simpler configuration, much easier to manage. We don't have any sort of weird configuration that we need to address and remember that we've got just for these VMs. They are now just VMs running VHDs. They just happen to have two VMs pointing to the same VHD at this point. Inside those VMs, we're still going to run failover cluster administrator, failover services, and we're going to configure everything. They're going to do all the same normal locking that they would do on those shared disks that they're talking to. So this gives us that ability to build this native feature and use that native feature. Big bonus here, no third-party software is required. Now, yeah, this is not going to work in Hyper-V. Hyper-V does not have currently the ability to do shared VHDs in Hyper-V, unfortunately. Hopefully, we'll get that at some point in the future, but not yet. And again, also, no iSCSI configuration required. This is, I know how a lot of us got around this requirement of needing either pass-through disks to be able to do a failover cluster in a VM. So we've gotten rid of that requirement. Yes in Hyper-V, no in Azure. Yeah, no Azure. Sorry, did I get that backwards? Sorry. It's been a long week, and I've talked to a lot of people this week. I'm surprised I still have a voice. So if we need to do failover clustering in Azure, we can. It is fully supported. It became fully supported on the best day to announce support for some features, April 1st, 2015. I keep telling Microsoft not to announce things on that day. Day before is fine, day after is fine, that day is not so great. We do require third-party solutions to make this work in Azure. So if we need that traditional failover cluster, we can do it. Again, we're going to use Sios Data Keeper. That is going to be the best option for us, as it is supported by Microsoft in the Azure platform. You can actually go into the marketplace and just search for Sios, S-I-O-S, and you'll actually find a 2-node cluster pre-configured that you can just install into your account and see it and play with it and see how it works. This is a single instance per cluster, so we cannot do a multi-instance cluster in Azure. So no building 4 nodes with 3 instances running on it. I'll tell you why in a second. I don't remember if there's a slide on it. So the requirement here is a single SQL Server instance per cloud service if you're running in classic mode. If you're running in resource manager mode, it's a single instance per clustered environment. The reason for this is because we need to use this construct or this object in Azure called an internal load balancer. So what this internal load balancer does is it looks to see which VM is running the SQL Server instance, and it needs to know that because it needs to know where to direct the network traffic, to which physical server and which VM on that physical server. So this is an extra object we have to create only when running in Azure. It also slows down our failover time. So I said on-prem, it takes about 6 seconds for a failover cluster to fail over. In Azure, it's going to take you about an extra 15 seconds. And that's because we need to wait for this internal load balancer to detect that the cluster has moved or the instance has moved from node A to node B, and then it's got to swing the traffic over. And it, by default, is going to wait 15 seconds. So it's going to check every 5 seconds, and it requires 3 failures before it's going to see that the thing has moved over. So you got about a 15-second additional delay, or potential additional delay, before that actually sees that you've moved that instance over. But in the grand scheme of things, that shouldn't be that big a deal. You're only going to be failing over when the host is rebooted due to patching, and Microsoft is working on getting rid of that, which I believe they announced this week, or if you reboot and because of patching one of your VMs. Other than that, the cluster should just stay online. Now, always on availability groups. This is our new feature introduced in SQL 2012. And it's been greatly enhanced over the last couple of revisions. We're going to talk through some of those enhancements that have been introduced by Microsoft. And this is our new availability solution and DR solution. Now, one of the really interesting things about availability groups over clustering is this is giving us the ability to have our high availability and our disaster recovery managed in a single solution. Now, failover clustering could technically do this, sort of. The sort of part is the storage replication piece. So let's think back to an on-prem configuration where we've got some sort of SAN storage. That SAN storage has to replicate data between the 2 arrays, between your production and your DR sites. When we go to fail over the instance from site A to site B, there's got to be some software on all the boxes to coordinate that failover to tell the production storage array that you're no longer production and to tell the DR array that it is now production. So there's some sort of coordination that has to happen there. In always-on availability groups, we don't have any of those problems. SQL Server is taking care of all of our data movement. It's taking care of all of our failover. Failover clustering is going to be involved here a little bit, but for the most part, SQL Server is doing all the work. So let's talk through how this is going to work for us. Oh, and the other nice thing about the availability groups over clustering, building a failover cluster from on-prem to Azure, kind of hard. Building a always-on availability group from on-prem to Azure, it's just like building an on-prem availability group. No special requirements other than that internal load balancer. So here are some of the components that you have to deal with when dealing with a failover cluster. Now this looks like a rather daunting list, but it's actually not that bad. Most of these are things we're already used to dealing with. Windows Server failover cluster, that's obviously something we're used to dealing with. We've been dealing with failover clusters for years. Asynchronous and synchronous movement of data, we're used to these concepts. We've had database mirroring have these for a good long time. They just had funny names in database mirroring. Synchronous commit, that's just simply a two-phase commit. Asynchronous is a one-phase commit, and we write it to the other box when we get around to it. Virtual computer objects, these are the same things we've had with failover clustering for years. We get some new things, availability replicas, automatic failover we've had, availability databases, readable secondaries, so a few new things, but for the most part, not that bad. Like all new things introduced by Microsoft, we have new terminology. So the first new thing to learn, new phrase to learn is availability groups. So that is the name of the feature. It is also a logical construct in SQL Server that's going to contain all the rest of these things I'm about to talk about. The next one is the availability replicas. These are simply the instances that are going to be hosting our SQL Server databases that we're going to be protecting with the always-on availability group feature. We also have the availability databases. These are just the databases that we're going to be protecting with this feature. We're going to be replicating them out to all the availability replicas. A database can be in a single availability group. An availability group can have multiple databases within it. An availability group is only active, or is only writable on a single replica at any one time. We then have the availability group listener. The availability group listener is going to be the network name and IP address that our users are going to connect to. So this is simply a failover cluster name and IP address registered with failover clustering, registered with DNS and Active Directory so that our users can come talk to our server. So this is the network name and IP address that's going to float from server to server depending on which one is currently the primary replica or the writable copy. So we saw what the graph for a failover cluster looked like. So this is a 3-node availability group. So in this case, we have node A, node B, and node C. Node A is our writable copy. Nodes B and C are our secondary copies. So in this particular case, we've got 2 cities involved. We've got Washington and Chicago. So the 2 servers on the left, node A and B, those are going to be in Washington, and node C is going to be in Chicago. So that's obviously quite a bit of mileage between those 2 cities. I don't know the East Coast. It could be like 6 inches, or it could be like 2,000 miles for all I know, because I live in California, and the East Coast is kind of a nebulous blur as far as I'm concerned. I know where my hub airports are, and that's about it. It annoys people when I don't know where things are on the East Coast, sorry. So between the 2 nodes in the city of Washington, we've got synchronous data movement happening between node A and node B. So things are moving with a 2-phase commit. So if they are written to node A, they are also written to node B. The command that we execute, the insert, the update, or the delete statement, does not respond back to the application that it's completed until it's completed on both of those boxes. Node C in this case is going to be asynchronous. Any data movement going more than 100 kilometers or so, we typically are going to recommend an asynchronous data movement for. The reason being is because of the speed of light. We're fighting against physics here. We can only move data from point A to point B so fast, and the latency that's introduced as we go over about 100 to 150 kilometers is going to be too far. That's about 80 miles for those of us from the United States. On top of these servers, we build our availability group. That availability group is going to be how we move the data, how we configure the data movement between all these. We then have our availability group listener. That's the white box at the bottom. That's our virtual computer object created in Active Directory, and it's got a name and an IP address associated with it so that we can register that in DNS so that users can come find us and not have to talk to us by IP address. Now, are our availability groups just mirroring? They seem kind of like database mirroring when you first start to look at them. And realistically, the answer is no. They're very similar, but they're not the same. Now, we use the same basic concept for moving the data in that we're sending a transaction log stream, or a TDS stream, between the 2 servers. We're using the exact same endpoint that database mirroring was using. So we're encrypting all our data as we send it across the wire. Now, some of the differences, probably the biggest difference, is we can have multiple secondaries as long as we're running Enterprise Edition. And those secondaries can be readable, so we can do things with them. This is a big difference from database mirroring. In database mirroring, we had to take a snapshot of the database, and it was a point in time, and we could only use it for until that data was no longer relevant because it was stale and because it was static. So now we can read and run reports in real time and watch that data change over time on any or all of our secondary replicas. As long as we're licensing them, we can use them. We obviously have automatic failover only to a synchronous copy. There is no automatic failover to an asynchronous copy because Microsoft's not going to take responsibility for for potentially losing data because of that failover to an asynchronous. So you have to make that decision to accept that data loss. Now, as availability groups were introduced, they were introduced as a 5-node availability group, a primary and 4 secondaries. Of those 4 secondaries, up to 2 of them could be synchronous. When we introduced SQL Server 2014, we actually doubled the size of the availability group. We went from 4 secondaries to 8, but still only 2 of those could be synchronous. Now, in either of these environments, we could set up automatic failover between any 2 servers. So we would configure our primary and one of our synchronous secondaries for automatic failover. That gets us our local HA, our local high availability. That's not necessarily good enough for some people. Some of us need or want more high availability than we can get from those 2. So, okay, I updated this slide. I don't know why it's not on this computer. It's not my laptop, it's theirs. In SQL Server 2014, we still have 8 secondary replicas. 2 of those are synchronous, 8 of those are asynchronous. The difference here is how many of those we can use for automatic failover. In SQL Server 2016, we can do automatic failover to all 3 boxes. We can do it we configure our primary and both our synchronous secondaries for automatic failover. How we control the priority of that failover is through the preferred owners list within failover clustering. This is one of the few things with the availability group that we can actually go touch in the failover clustering configuration. If we need more levels of availability beyond what we're getting with always-on availability groups or with failover clustering, we can actually merge these 2 approaches and get failover clusters built with always-on availability groups on top of them. So this is going to allow for additional redundancy and give us additional abilities to scale our availability solution. So one of the great use cases for this actually came up during the beta period for SQL Server 2012. One of the credit card processing companies was building out a proof of concept on SQL 2012, but the requirement was 3 data centers with 3 servers at each of their primary and secondary data centers. Well, that's a total of 7 servers. Now, as I am a student of the American education system, even I know that 7 is more than 5. So we had to come up with some sort of solution. And the solution they came up with was use failover clustering at their primary and secondary sites. So that's 3 nodes at each of those sites, and then 1 node over here in their tertiary site. So with the 3 nodes at each of these sites, they built those as a failover cluster. 1 copy of the data, yeah, that's okay. But then that's only 1 instance or 1 replica at each one of those sites. So they only had 3 replicas within the environment, even though they had 7 servers behind the environment. So that gave them the high availability that they needed to get that solution built and approved by management to be used without having to go outside of the available configuration in SQL Server 2012. So we can still do that today in SQL Server 2014. So we still have lots of options for moving data around and keeping things up and running. Now this does change how automatic failover is going to work for us. This is one of the limitations of going with this particular configuration. When we use failover clusters with always-on availability groups built on top of them, our failover point is at the failover cluster. This will automatically disable the ability for the availability group to automatically fail over back and forth between replicas. The reason we don't want automatic failover between the replicas at this point is because if the failover cluster fails over, that would then trigger a failure of the availability group and cause it to fail over as well. So we don't want that because we want the availability group to just stay where it is on the failover cluster because that's our first level of high availability. So we wait for the failover cluster to fail over and come online. If we need to move the availability replica off of a failover cluster to another replica within the environment, we'd have to do that failover manually from one site to another. So it changes how we need to think about the availability group a little bit, because it changes some of the supportability and how we need to interact with this in a high availability solution or in a potential local disk failure. Now, we had failover clustering. That's supported by everything, because that's just an instance. All features are supported in failover clustering. With database mirroring, we had support for, with database mirroring, we had support for some features. Not a whole lot of cross functionality between a lot, especially the newer features. They got left out of the database mirroring workload. With always-on availability groups, that's not necessarily the case. We actually have cross-functional support with basically everything. Now, there's two caveats to that. I'm going to tell you. I'll get the rest of these on the slide here. So that's a good set of features, and it's compatible with everything. The two things that are not cross-compatible between availability groups and the rest of the database engine is that little asterisk next to column store indexes. In SQL Server 2014 and 2012, in 2014, clustered column store indexes were not readable on the secondary replica of an availability group. You could read them on the primary, and you could write to them on the primary, but you could not read them on the secondary. That was resolved in SQL Server 2016. If you went to the session this morning at the ungodly hour of 9 a.m., down in 211, that my colleague Joseph Diatoni did with Atom Data Solutions, they're one of our customers, they actually were using that in beta with Microsoft to solve some of their performance problems, some of their scale problems. The other feature that is not supported in an availability group that's a native SQL Server feature is the distribution component or the distribution database of a SQL Server replication topology. Your only high availability solution for the distributor of your replication topology is a failover cluster. The reason for this is the jobs. All those jobs have to be able to run on the distributor, and with the availability group, with things moving around, the jobs may end up on a different server. So that is not supported in an availability group. But that's two limitations of two relatively small features, or one new feature, one relatively small feature, compared to everything else. That's not that bad. Now, we've talked about a lot of things kind of more in an on-prem sort of talk. So let's talk about doing a hybrid availability group. Let's take our on-premise environment, our on-premise availability group that we have today, and stretch it out into Azure, into the cloud. So we simply set up our site-to-site VPN between our on-prem environment and our cloud environment, install some domain controllers out in Azure, and our Azure is now it's part of our corporate network. It's part of our environment. So we can now build VMs in that environment and do asynchronous data movement up to that environment. So this is going to allow us to deploy multiple replicas, if we want to, up to that environment. And there's a new feature that I'm going to talk about in the 2016 part of this that's very, very important for this and makes this very, very cool and even better and easier to deal with. We're going to need to have continuous synchronization up to those boxes. So we're going to need a decent amount of bandwidth, possibly ExpressRoute, depending on what our network looks like. We can pick the best region that's available to us. I live in Southern California, so obviously US West, probably not the best place for me to put my DR environment. So I can pick US Central, I can pick US East, I can pick somewhere in Europe or in Asia. I've got lots of options. Just depends on where I want to put my data and what my locality laws for the data that I'm storing are. So obviously there's some political considerations you're going to need to deal with. If you're in Europe and you're storing European customer data, you probably don't want to be putting that in the United States, as that's against the law. Same goes with Canada. Same goes in most countries. We're not very popular right now in some places. Also, there's the network latency to take into account. Where are your users coming from? If your users are all here in the US, putting your DR facility in Southeast Asia, probably not the best idea. Unless, of course, you're building a physical DR facility, in which case Southeast Asia is a wonderful place to vacation on the company dime. Just saying. Nice thing about the cloud, when it comes to our DR environments, relatively low cost of ownership. We don't need to spin up hardware. We don't need to go buy and deploy hardware. You've all heard the sales pitch before. Really cool thing about Azure, I'm just going to briefly highlight it because some of my customers love this. Our DR environment can be built really small. We can build it with 2 or 4 core VMs, 8 core VMs, as long as we've got enough CPU resources to handle the rolling forward of the transactions. We don't need to have like-for-like hardware running in VMs in Azure. This is one of the big selling points of putting your DR for databases in Azure versus in a physical environment in a colo somewhere. Is because in the colo, you've got to pre-buy all that hardware, and it's going to sit there doing nothing for you. In an Azure environment, we put those availability group replicas in Azure. We make them relatively small as we can get away with. In the event of a disaster, part of our DR plan is to make those boxes bigger and more expensive. So we can save money on our DR costs that way. So if we were to build an availability group, stretching between our on-prem environment and Azure, this is basically what it's going to look like. We've got 2 nodes there on-prem on the left. We've got our 3rd node over there on the right. And that's up in the cloud. That's a stretched availability group between them. So one name. We've got 2 IP addresses, 1 on each side. Remember that multi-site failover cluster, or multi-site subnet, multi-subnet failover, there we go, feature that I mentioned earlier. We're going to be using that same functionality here. Again, that was a Windows component, a Windows function that we're going to be using. We've got our site-to-site VPN, however that's configured, probably through a router on our front end or through our firewall on-prem. In Azure, we're going to use an Azure Gateway. Then we've got our internal load balancer that's keeping an eye out to see if our cluster or if our availability group IP address comes online. So it's the exact same thing we do on-prem. The only additional component is that internal load balancer. Once we spin that up, the whole thing works and fails over, and our users can connect back and forth without issue. Now, when you're using any of these multi-site features, or the multi-site, multi-subnet features, either for failover clustering or for availability groups, one of the things to keep an eye on is the fact that Microsoft made we'll call it an interesting decision when they introduced this feature. So we've got our server component, which is SQL Server, and we've got our client, which is whatever client you're using. So by default, when the SQL Server fires up for the first time in a multi-subnet configuration, it's actually going to register both IP addresses in DNS. The reason it's going to do this is so that you can add a parameter to the connection string, which tells the ODBC driver to go connect to both of those IP addresses, see which one responds, and connect to the one that responds, which is cool. It makes our failover very, very fast. Think about a large enterprise that's got 10 sites around the world, and I failed over production from one site to another. Without this feature, I've now got an updated DNS. I now need to wait for DNS to replicate. That may take half an hour, an hour, depending on how we've configured things, for that IP address change to replicate out to all my sites. With this feature, there's no DNS change. DNS already has both names or both IP addresses registered in it, and the users connect automatically. Now, the reason I say that there's an interesting decision that's been made here is the server uses this two IP address configuration automatically. The ODBC driver does not. You have to tell the ODBC driver to go do this. So you'll need to either go tell the ODBC driver to do this by adding in the attribute into the connection string, or you'll want to turn this feature off, preferably before you set up the second subnet so that it doesn't go register in DNS. When we're in Azure, we have the exact same functionality. It's going to do the exact same thing. So you need to make sure that all our clients are able to talk to Azure so they can see if that IP address is responding or not. So why do we want to put our DR in Azure? Why would we set up a stretch availability group between our on-prem and our Azure environment? Well, obviously, for DR, there's a large, large list of events that can cause our on-prem SQL servers to go offline. There's all the boring stuff, the servers reboot, some idiot unplugs the rack, somebody's kid pokes that really tempting looking big red button on the wall. It's happened. And then there's the not so fun things, earthquakes, floods, fires. I've been evacuated from multiple buildings for various reasons. Unfortunately, bomb scares was among them. We used to get bomb scares weekly at a company I worked at. It was a lot of fun. Any sort of temporary failure where that site is not going to be available for some period of time, we need DR for. We need to be able to bring those systems back online. DR is expensive. Physical racks cost money somewhere. Don't care where you're putting them. On top of that, you've got to buy a few servers. However big your production environment is, your DR environment's going to be about that size. We need operational costs. We need people to get things up and running. We need people to handle the failover. Something that most companies don't think about, that I bring up with every one of my clients when I'm doing a DR plan, because most of them have their servers local to them. Who's going to initiate your DR plan? Assume that you're not there. Assume that nobody in your staff can get online. I'm from California. We have these annoying things called earthquakes. Best case scenario, the power's out and the cell phone towers are down. That means the internet's out. That's best case. Reality is, this is the depressing part of the presentation, sorry. Reality is, bridges are down, airports are closed, trains aren't running. How am I going to get my local staff somewhere they can get internet access? Assuming, and we hope that this is the correct assumption, that there's somebody to have go there. I live in earthquake country. This is a reality. We do something in California that nobody else in the country does in our data centers. I found this out by accident once. We bolt our racks to the ground. Nobody else has to do this. Well, until recently, nobody had earthquakes. I found this out by accident when I was sitting in one of my customers' colos, and I leaned against the EMC array, and it moved. Never happened to me before, because all of my colos had been in California. Obviously, one of the other problems with DR is things can permanently change. If our data center isn't available anymore, it's not available anymore. It may take months to get a new data center built. One of the things that makes things very expensive in data centers is also cooling. Power is cheap, air conditioners are not. So keeping those things running takes a lot of power, requires that we keep things moving. So if we're going to have DR, let's use it for some other stuff. Let's integrate our HA and our DR. Let's offload some reads. Let's make our DR environment do some work. Most DR environments just sit there stagnant, just chewing up money. CFOs love things that waste money. So wouldn't it be nice if we could go to our CFO, go to our finance team and go, yes, we know we're paying all this money to Microsoft for these extra licenses. Yes, we're paying for this, either this hardware in DR, in physical DR, or in the cloud. But we're able to use it. We're able to run reports. We're utilizing this hardware to do something. We're really getting something for our money. So we can run backups in our DR environment. We can run reports against our DR environment. If we've got our DR environment in another office, we can have users running ad hoc queries against those other environments, against those DR environments. We've got some options there. We can offload our backups to Azure. We can push our backups straight up into the cloud. If our VMs are running in Azure already, if our DR boxes are running in Azure already, running backups to Azure is going to be really, really fast. There's a really fat network, really big network pipe between the VMs in Azure and the rest of Azure, because it's in the same building. Now, there are some requirements up through SQL Server 2014 that we need the same Windows domain, and we need an Active Directory domain controller in the cloud. Now, this is going to change in SQL Server 2016. In SQL Server 2016, when running on Windows Server 2016, now keep in mind, I built these slides before Monday, so my bullet points were accurate when I submitted them. As of now, we no longer need Active Directory in both sites. We can now do domainless clusters and domainless availability groups. Some guy's liking this over here because I'm getting, you know. So this is a good thing. This is great for environments that have separate Active Directory domains in each site that have set this sort of stuff up. So we can now get more flexibility when building these environments. So SQL Server 2016, relatively new release. That's why it gets its own section, why it's not bundled in with the rest of this. So what is new in SQL Server 2016? Based on the size of that stripe, you can probably tell there's a few things for this slide. Database level failover triggers. I've got slides for all of these. Distributed transaction coordinator support. This is a big deal in SQL Server 2014 and below because we could not use distributed transactions in an availability group. Better support for automatic failover. We'll talk about this more. Log transport performance got better. We can load balance across our readable secondaries in a Microsoft-supported solution. We've got group managed service accounts in Active Directory. So clearly this guy's a sysadmin. He's nodding at all the sysadmin stuff. We've got now what are called distributed availability groups. Again, I'll describe that in a minute. We've got availability group seeding. This makes deploying these things much easier. And domainless availability groups. I think that's all of them. Yeah, that's all of my bullet points. So let's run through these. So database level failover triggers. In SQL Server 2012 and 2014, our availability group health was determined at the instance level. Now, availability groups are a database level high availability solution, but we're only detecting for failure at the instance level. So if my database goes suspect because the LUN drops out from under my database that's protected by an availability group, nothing happens. That's by design. In SQL Server 2016, we solved this problem with an optional setting that we can turn on within the instance that allows a database to figure an availability group failover. So if the database goes suspect, if the disk drops out from under it, if something horrible happens, the database setting will change the health of the availability group, and the availability group will now fail over to another replica within the environment. The assumption being that next replica is healthy because it's got separate disks. That's the whole point of this. Everything's totally independent. Distributed transaction coordinator support. Up until now, up through 2014, distributed transactions were not supported. This is a problem because a lot of large enterprise class applications require a distributed transaction to work. What a distributed transaction is, for those of you who are not database folks in the room, is it's a transaction that spans across multiple servers. So we may have an application server that spins up a distributed transaction within .NET code, stores a file on a file server, goes out to the database, inserts a row into the database, and then goes off and makes a web call to get some information about the customer that was just done, maybe to a partner website. Well, if the database called the partner website fails, we want to be able to delete the row and delete the file. Because we're in a distributed transaction, all we need to do is fail back the transaction, or roll back the transaction, sorry. And that'll cause everything to roll back and everything to be deleted. But that's not supported in availability group, so we had to do it in a failover cluster. So as of 2016, we have support for distributed transactions in an availability group. Now, this requires an OS patch to work, and there's a caveat. It's only supported on a single database within the availability group. So if your distributed transaction requires multiple databases in your distributed transaction, that is unfortunately not yet supported. You can only have a distributed transaction on a single database at a time. They're working on it, I'm told, and when it's ready, they'll release it. But it's not yet available, and I don't know when that's coming. But so that should get us support for most applications. Some, sorry, just aren't going to work yet. They're still going to need to stay with a traditional failover cluster. 2012 and 2014, like I mentioned earlier, only supported automatic failover to a single target. So when you configured automatic failover, you would select the primary and one of your synchronous secondaries. In SQL Server 2016, we can failover to any of our synchronous copies. We can configure that automatic failover support. So basically, we just select both our synchronous secondaries and our primary for automatic failover support. That gets us a better level, a higher level of high availability. The log transport performance has been radically improved in SQL Server 2016 to the tune of about 20%. Before, I would tell customers Microsoft can probably handle 95% of workloads within an availability group. I'm a realist. It's not going to handle the highest of the high end. In SQL Server 2016, I would say 97, 98% of workloads. We're getting a lot closer. That's a lot more workloads to be able to handle. Microsoft was able to do this by reducing the level of compression a little bit, by removing compression between synchronous copies, because those copies are designed to be in the same data center. Network bandwidth isn't as much of a concern inside a single data center as it is across multiple data centers. And they rewrote the entire code stack for all this transport from scratch in SQL Server 2016. So radical, radical improvements in the performance in 2014, 2016. Yes, sir? So yeah, the question was, is there two different levels of compression between synchronous and asynchronous? And technically, yes. So there's no compression on synchronous, where there is compression on asynchronous. So your network bandwidth requirements will be different between those. So something to keep in mind when planning out your network deployments. And I can help with that for DR and stuff like that. Give me a few slides. So hardware enhancements, specifically SSDs, are obviously driving more throughput to our databases. So that's one of the reasons Microsoft made such an investment in improving this log transport performance, because that was a bottleneck on the really high workload servers. Their goal, as I've been told, is to match standalone server performance. I mean, that's a fairly obvious target to try and hit. I don't know how they're going to hit that. The laws of physics are playing against them, because we have to move electrons from point A to point B. As soon as they figure out how to put a wormhole on a TCP/IP network, I think we might be able to get there. Until then, there's going to be some sort of tiny, tiny delay as the bits move from point A to point B. We can do load balancing across our readable secondaries. So in SQL Server 2014, and 2012, we had a feature called read-only routing. What this would do when configured was it would route network traffic to a specific VM or specific availability group replica when a server was primary. So if in my diagram here, if AG1 was my primary server, and it was configured to send the traffic to AG2 as my read-only routing target, all traffic would go to AG2, AG3 and 4 would just sit there doing nothing. When I turn on this feature in SQL Server 2016, I can now use round-robin load balancing to round-robin the network traffic across all of my secondaries. So if AG1 is my primary, I can now tell it to round-robin the network traffic across AGs 2, 3, and 4, and it'll keep the workload relatively well balanced. Now, keep in mind I said this is round-robin. They're not doing any sort of polling of the servers to see which one's CPU is the highest or anything like that. It's just a simple round-robin of the connections across those servers. So will we get something better in the future? Who knows? But this is pretty good. Now, up until now, we had to do this with a hardware load balancer in front of all these boxes to make all this work. And frankly, I did that at a tech ed presentation when SQL Server 2012 had just come out, and it was kind of cool. But now that we can do this without needing the networking team, we can do this without any sort of extra configuration, that's a much, much better solution for us to have. Now, anybody here like changing passwords? One guy thought about it and realized that was the wrong decision. So password management, obviously royal pain. So we have group managed service accounts. Now these were introduced back in the good old days of Windows 2012, the olden days, also known as like 4 years ago. These were supported in SQL Server 2016 for standalone servers. They are now supported for SQL Server 2016 with availability groups. So we can now, one of the requirements of an availability group, highly recommended configurations of an availability group is to have all the instances running under the same domain account. So obviously, if we need to change the password for that domain account using a normal user account, we would have to restart all those instances at once and take the entire environment offline. Not a great solution for our incredibly important Tier 1 application that we're spending a small fortune getting configured and set up. So now with the managed service account, or the group managed service account, we can configure all the instances to run under the group managed service account. And when it comes time for the password to be changed by group policy, Windows will change that password automatically. It will update all its local SAM databases, and it will tell the SQL servers to use the new password for the running service without restarting any of our SQL servers. Pretty cool feature, allowing us to actually do password changes on our service accounts, because I'm sure we all do that on a fairly regular basis, right? We all change those every 30 days like we're supposed to? Yeah, I didn't think so. Nobody does, because it's a royal pain. So how we configure those is we simply go in and we configure the service to run under our group managed service account. The big difference here is we put that $ at the end. That is what tells the Windows services and the Windows operating system that we are using a group managed service account and not a regular Windows account. Once we've done that and we've restarted all the boxes, we can do that as a rolling process across all the machines. Now everything's running under the group managed service account and everything just works as expected. Now, probably one of my 2 favorite features in 2016 is the distributed availability groups. So these are going to allow one availability group to treat another availability group as a secondary replica. I have a diagram. It's okay. This also allows us to build our availability groups across Windows clusters. So we don't have to have all our availability group replicas in a single Windows failover cluster anymore. Next reason is we love this. This is my favorite bullet point. This is great for minimizing network traffic across the WAN between your HA and DR. Now, in all the diagrams I've shown you before, all our network traffic to every secondary comes from the primary server. So if I've got 4 boxes in production and I've got 2 boxes in DR, and they're both secondary replicas, up until today, when I wanted to feed those 2 boxes, I had to double the amount of bandwidth that I needed from having a single box, because both boxes had independent feeds from production. Now, last MVP Summit, 2 MVP Summits ago, MVP Summit, we go to Microsoft and we tell them all the things we want them to do, and they tell us they're not going to do any of them, just so you're aware. I'm up there, and I'm talking to the PM for always-on availability groups and high availability in general. And I give him my awesome idea, and I diagram it all out, and he's sitting there going, yeah, that's already in the product. I just didn't know about it yet because they hadn't released a beta to us yet. And it does this. This is exactly what I asked for. So I'm taking full credit for this feature being put into the product. The fact that they had, thank you, the fact that they had already written the code is totally irrelevant. And it has nothing to do with Azure. Yeah, this is totally how SQL database in Azure works. So this is great for migrating things between environments. If you're changing AD domains, if you need to move from your old Windows 2012 R2 cluster to your fancy new Windows 2014 cluster, we can do that using this technology because we can just spin up a new cluster next to it and move stuff around. I promised a diagram. There it is. So we've got 2 availability groups in 2 separate failover clusters. And all around that, we've got our distributed availability group. So as we can see, let me bust out ye old virtual laser pointer. So here is our primary. So this is the box that our customers are writing to, our users are writing to. And it's feeding these two secondaries down here. It's also feeding, through the distributed availability group technology, this primary over here of this second availability group. I've just cut my network requirements, my network bandwidth requirements, in half. If I added another secondary in DR, either for more reporting or just for additional availability within the DR environment, I've now cut my network requirements by 1/3. That's actual money that we can save. So that's pretty cool. That's pretty handy. Another great feature we have, availability group replica seeding. Setting up an availability group is a fairly straightforward process. We configure everything. We take a backup of our nice small 10 terabyte database. We copy that to the next server, and then we restore it. We do the next server, and we do the exact same thing. Huge pain to do, especially on large databases. With availability group replica seeding, I can actually push the data from my primary server to all my secondary servers without a backup and a restore, without having to stop my transaction log backups to push this stuff around. You can clap louder, it's cool. There we go. I wish I could take credit for this one. So this is gonna feed the database across the network without that backup. So we can just tell it alter availability group, seed, blah, 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 whatever the parameters are. I don't remember off the top of my head. And it will just simply push all that across. Most importantly, it does not break the log chain. So we don't have to stop taking transaction log backups while we're doing this. And if we're gonna leave the backups on, traditionally, we've then had to go restore all these logs that have been accumulating while this backup process has been running. We don't have to do any of that anymore. It just feeds all that data across the pipe. So the question was, have we tried it, and does the transaction log continue to grow while this whole process is running? Yes, Joey just did it like 2 days ago, maybe yesterday, on a customer system while he was here. Joey's the guy that was sitting up here that just ran out of the room. And yes, the transaction log will continue to grow because it's got to buffer all those transactions in the transaction log until this process is done. So you will need enough drive space on that log drive to support however long this process takes. But I'd rather have that problem than be moving terabytes of data around manually through batch files, because I hate myself. Another cool feature, we've been asking for this since database mirroring was deprecated in SQL Server 2012, is availability groups in Standard Edition. So we have a new HA technology that is supported for SQL Server Standard Edition. So the caveats, because it's Standard Edition. It's 2 nodes only. Only 1 database per availability group. There are no readable secondaries. There is no backup on secondaries. You can take database snapshots. So this technology should look fairly familiar. It's basically database mirroring. It's the same features of database mirroring that we were looking at before that we now need. So I'm a couple minutes over, unfortunately. So what have we covered? We need to understand our business needs before we design our HADR strategy. One of the things that I hate seeing when I go to clients is that IT is driving the decisions of what we need for HA and DR. That's not our job. Our job is to implement and design. Building requirements, it's the business's problem. They need to tell us what they want. After they tell us they want no data loss and 0-second failover, and we tell them how much that's gonna cost, then we can work with them to get some more realistic numbers. After we've done that, then we can design the solution. But we as IT professionals shouldn't be, at least in my humble opinion, should not be dictating what the recoverability is to the business. If they're willing to pay for it, we can design it. DR is just like buying insurance. You don't need it until we need it. There's lots of good options for HA and DR within SQL Server. It all depends on how much you want to pay and what you want. So if the business doesn't want to pay to have 3 copies of the data, but they want DR and they want always on availability groups, but they only want standard edition, well, we have a problem. We need to pick the right solution. That solution in that case would be enterprise edition. Obviously, always have a DR plan. So what do we want to do next? Go download SQL Server 2016. It's been out for a couple months. We've had a customer on it for over a year. Joey gave a presentation on it this morning, which you can watch the recording of once they're published on Channel 9. Deploy the SQL Server 2016 availability group template in Azure and go play with it, go explore it a little bit. If you don't have an Azure account already, you can obviously go sign up for one. You'll get $150 US of credit. Build your availability group small. It's going to get expensive fast to keep it running. You can burn through that fairly fast. Or come talk to us down in the booth, in the data platform booth. It's right in the middle when you go down the main stairs, or main escalators, into the exhibit hall. You've got a good number of people from the product team there. You've got a bunch of SQL Server MVPs like myself there to answer questions until 4 o'clock when they close it. So you got 2 hours and 9 minutes. Go check out all the available resources that Microsoft has available to us. Apparently, we can get $300 in free credits and some extended trials this time around. Go check out Pluralsight. Use the phone support that we've got available to you. Just go talk to Microsoft about that stuff. There are some URLs you can get that. Don't forget to do your surveys. That's how Microsoft knows whether or not they want me to come back or not. Please give me a good score. I like coming back and talking to you guys. Unless you hated the session, then honestly, be honest. Thank you all very much for coming. I'll leave that up on the screen.